Hi, my name is Catherine Métayer. I am professor of epidemiology at the University of California, Berkeley. The goal of my research is to better understand how the environment and diet can influence the risk of cancer in children. There are many sources of outdoor air pollution, including emissions from various modes of transportation, industrial, agricultural, and urban sites, as well as natural causes such as wildfires. High temperatures can also increase air pollution levels. More than 90% of children worldwide are exposed to unhealthy levels of outdoor air pollution, and their developing bodies are more sensitive to harmful effects of air pollutants. Air pollution is a mixture of particulate matters, chemicals such as benzene and other volatile organic compounds, polycyclic aromatic hydrocarbons, nitrogen dioxide, and metals. These contaminants have the potential to increase chronic inflammation, oxidative stress, and DNA damages, which are known to contribute to carcinogenesis. It is not surprising that air pollution has been found to increase the risk of cancer for organs directly in contact with air pollutants, such as lungs and upper aerodigestive tract. More recently, air pollution has also been associated with cancer of distant tissues, such as breast cancer and lymphomas. Based on mechanistic and population-based studies in adults, the International Agency for Research on Cancer and the US EPA have classified benzene, polycyclic aromatic hydrocarbons, and cadmium as human carcinogens. But what do we know about the risk of cancer in children? Air pollution and its impact on childhood cancers has been extensively studied in different parts of the world. These studies use different ways to quantify exposure, from less precise, such as proximity to source of combustion emissions, to more precise with actual measurements of air pollutant with air monitors. A study pooling air monitoring data from several studies in Europe, Asia, and North America showed that the risk of developing childhood leukemia increases with increasing levels of benzene, butadiene, and nitrogen dioxide, as shown in red in the table. Results using traffic density as an indirect measure of air pollution were null. A closer look at the dose-response relationship between the risk of childhood acute myeloid leukemia and air levels of benzene reveals that the risk increased sharply even at low levels of benzene, suggesting that there are no safe levels. Air pollution has been associated with other cancers in children, including brain tumors, lymphomas, and embryonal tumors. For example, a study conducted in Sao Paulo, Brazil, showed higher incidence rates of childhood lymphoma in areas with highest level of air pollution from traffic emission. Another study conducted in Texas showed higher incidence rates of childhood liver cancer in areas with highest level of air pollution from industrial sources. More recently, concerns have emerged about the health of pregnant mothers and children living in proximity to unconventional oil and gas development, which can contaminate the air and the water with chemicals and radiological agents. Several epidemiologic studies, including one conducted in Pennsylvania, documented increased risk of leukemia in children whose mothers lived close to fracking wells from the time of conception up to the child's birth. Adults and children are also exposed to air pollution inside their homes from various activities such as cooking, cleaning, and smoking, which emit the same types of air contaminants and carcinogens as we have seen for outdoor air pollution. For example, polycyclic aromatic hydrocarbons emitted in the air are deposited on surfaces and accumulate in home dust, which becomes a reservoir of persistent chemicals. Young children who crawl on the floor and touch surfaces are particularly vulnerable as they can be exposed to contaminated dust via ingestion, inhalation, and skin contact. In a study conducted in California, we collected house dust from homes of children diagnosed with leukemia and healthy children and found that several polycyclic aromatic hydrocarbons were associated with an increased risk of leukemia. In summary, both outdoor and indoor air pollution contains mixtures of chemicals, some of which are known to be carcinogenic. Many studies around the world have documented that air pollution increases the risk of several types of childhood cancers. This body of evidence strongly supports the need for preventative measures to reduce air pollution burden in children and reduce cancer risk.